And welcome to the Daily Space Weather. We've got unexpected geomagnetic storm conditions as a result of a sudden shift in the field. We say on the channel all the time that the magnetic environment can suddenly change with basically no warning, which is what we're seeing here at the Smash News Network, least busted name in news. Whew. Starting out with a classic view here, just 304 angstroms, ionized helium by itself. That is the past 24 hours. Lots of sunspots, lots of filaments. Let's add 193 angstroms to help highlight all of those filaments. You can see some of these dark absorption features down here in the south especially. Lots and lots of filaments all over the Earth-facing portion of the solar disk. Let's change out 193 angstroms for 171 angstroms. We've got some active regions setting in the west and some active regions rising in the northeast, possibly also in the southeast. Sunspot number should drop today, and let's take a brief moment to take a look at Crescent Earth to see what's going on in terms of volcanoes and earthquakes. First, the SDO intensity gram yesterday plus today. Most of those groups stable. We've got some evaporating sunspot groups in the northern hemisphere. Also, right around the equator, some groups evaporating there. Besides that, most of those groups remaining largely stable for the past 24 hours. Here's your colorized magnetogram. We may have a new sunspot forming down here. That does look like it's gaining magnetic organization right down there. And let's take a look at volcanoes. So Shiveluch continues to erupt here. It's producing a 22,000-foot plume of volcanic ash over Kamchatka. That is an uptick at Shiveluch. Sakurajima, about a 4,000-foot plume of volcanic ash, flight level 040 over Sakurajima. Suwanosejima, that is a flight level 060, 6,000-foot plume of volcanic ash. Next, looking at Indonesia here, Karangetang. No indication of the size of the ash plume, if any, there. Although there was a lenticular cloud spotted. Lenticular clouds, they often convince people of things that aren't true about atmospheric science. Volcanic alert level remains at level 3. Siaga, whatever that means. Carinthia exploding, flight level 130 over Sumatra. Popocatépetl exploding, flight level 200. It's a 20,000-foot ash plume over central Mexico. And moving to Central America, Fuego in Guatemala exploding, flight level 150, 15,000-foot ash plume. Moving down to South America, volcanic ash has been dispersed at Nevado del Ruiz. Perhaps a lull in the action for Colombia. Next, moving to Ecuador, Sangay exploding, flight level 190. Revenador exploding, flight level 150. Cotopaxi, no volcanic ash emitted from that. Cotopaxi and Sabancaya, last but not least, exploding. Remains in orange alert. It's producing a 25,000-foot plume of volcanic ash. It's a flight level 250 over Peru. Next, looking at seismicity. Yes, seismicity. For the past 90 days, there's the convenient bar graph. We did have a significant earthquake in Hawaii. We'll get to it here briefly. It was nearly a 5 magnitude. And I think the largest of the past 24 actually was a 5.6 at Romania. That one came in at 13:16 Universal Time yesterday. And let's scroll up the list. Feel free to leave a comment if we miss anything that you thought we ought to have covered. So Tonga also had a 5.3. A bunch of quakes there north of New Zealand and on the North Island of New Zealand. No major quakes. No major quakes, period. But there were 2 central mid-Atlantic ridge quakes, a 5.2 and a 5.1. Only about a minute and 15 seconds apart approximately. And that was 2:13 and 2:14 Universal Time this morning. I stand corrected. The largest quake of the past 24 was a 5.7 in the Cook Strait. Oh, it was between the islands. Okay, the strait between the islands there. 5.7 magnitude quake. And this 4.8 is interesting. It did occur south of Kilauea there in the ocean, south of the Big Island. 4.8 at Hawaii, largest quake we've seen there for a while. Also, Alaska had a 5.2 way out in the Aleutian Islands. And before we get back to space, take a moment to check out our links. If you haven't seen the links below the video, check out the Smash Team page. That is our official subscription services site. Consider becoming a gold or silver Smash Team member if you'd like to support the content as we make just this side of nothing on the junkware platform of YouTube. Of course, we insist that Google fix its junkware, but we don't expect that to happen anytime soon, so we created our own subscription services site, smashomash.com/SmashTeam. We put up additional content on there for gold and silver Smash Team members. There's also a gold annual paid-up subscription. There's also a bronze membership that won't cost you a dime. We also send out email alerts when our videos go out because we don't trust certain organizations to notify our viewers when the content goes up. Today's featured product is, and it can be found below the video if you click the links to the Redbubble shop, do not pole vault the caldera. No matter how bad things seem, don't worry, they can get worse, but they'll get better. So our finest days lie ahead, folks. So if you're going through hell, keep going. And if you're going on a volcanic vacation, leave that vault pole at home. Don't pole vault the caldera. It could be unhelpful. We need the views on YouTube. Ha ha ha. Hilarious, right? Don't forget to press the like button. If we see 50 likes, we will do a YouTube live stream. Those 50 likes have to occur in the same calendar date on which the video was released. Anyway, give Smash staff a raise by picking up some merch, perhaps, like the Do Not Pole Vault the Caldera design, our top seller. And that's what you'll find if you click the link below the video to the Redbubble shop. You'll find our products in order of best selling. So check those out if you haven't seen them before. There are some. And let's get back to space, since we do have a geomagnetic storm condition happening as we speak. So here's some more 24-hour SDO videos. That's 171 plus 335 angstroms. Shows some great definition of the solar corona there, bright regions, magnetic looping features. We've also got 171 plus 131 angstroms, a different portion of the electromagnetic spectrum. All those AIA views from SDO are all part of the extreme ultraviolet light spectrum, not visible from the surface of Earth. They have to be viewed from space, as those bands of the electromagnetic spectrum are filtered out by Earth's mesosphere. The 10.7 centimeter radio flux has dropped all the way down to 180 solar flux units, and we can expect to see that continue to drop unless we see some new sunspots form, which is always a possibility. There's the one-year graph to put it in context. The black line is the radio flux. The red line is the sunspot number. Perhaps you can see how proportional those are. The radio flux and the sunspot number are indeed directly proportional solar data sets. So again, we've got some unexpected geomagnetic storm conditions here. NOAA wasn't forecasting it. They were expecting a little uptick here, but not what we got. And what we got is caused by this strong magnetic field change. A prime example of how the magnetic environment can suddenly change with basically no warning. It's a coronal hole high-speed stream shock front. We'll show you more data on that. So we did have over a KP5 there, the most significant geomagnetic storm we've seen in quite some time. Current conditions are KP 4.67, so it's a minor geomagnetic unrest / geomagnetic storm condition. And let's take a look at Earth's magnetic moment from space. So this imagery should depict the last 4 hours. It's showing you magnetohydrodynamic pressure in the units of nanopascals. It's modeled by the Space Weather Modeling Framework. If you want to read about that, click the Details tab down here, and that'll provide a link to the Space Weather Modeling Framework. You can download all the software and view it for yourself. Next, ground magnetic perturbations for the same period of time, the last 4 hours. This will show you the most likely places for the viewing of the aurora, also railway, pipeline, and power grid induction. That's Earth's magnetic moment from the ground, depicted in nanotesla magnetic flux density, and also for the last 4 hours if everything's going according to plan, which it looks like it is. We'll also show you the 30-minute auroral forecast, as we have seen some aurora And we typically share that imagery on Twitter, so make sure you follow us over there. If you don't have a Twitter account, why not get one? Tell Elon Musk to get rid of the shadow bans, aka deboosting features, and other ridiculous nonsense, violating the civil rights of Americans. Anyway, that's your auroral oval. I'm not going to let that play through again. I'm going to move on to the real-time solar wind. So we saw this uptick in the solar wind density. It made it up to about 25 protons per cubic centimeter. That is a prime example of the shock front, the high-density wave at the front of a coronal hole high-speed stream. Very characteristic. And you can expect to see this solar wind density dropping off as it is now, and the solar wind speed to come up to like 600 kilometers per second. So current situation is only 330 kilometers per second for the solar wind speed, solar wind density, just under 14 protons per cubic centimeter. And what's really causing the geomagnetic storm conditions is this top pane. So this top pane up here, this is the BTBZ, which is the total magnetic field strength. That's the BT, that's this white line. And the BZ is this red line down here. That is the vertical component of the magnetic field. And when we have a strong negative BZ, it induces more electrical current around the planet, and that's what causes the geomagnetic storm conditions. So we saw a big increase in the magnetic field strength and a big negative BZ signal. So that 11 nanotesla for the BT and the negative 8 for the BZ is the main reason for the geomagnetic storm conditions. And let's move on to some additional data here, since there is plenty to cover indeed. Okay. Let's try again. And we're looking at magnetic data next. And you see these spiky readings. Those are consistent with coronal hole high-speed streams. Those are your GOES magnetometers for the past 3 days. And let's take a look at the heliospheric current sheet next. And welcome to the North Magnetic Pole. So you are in the North Heliospheric Magnetic Pole at the moment. You can see all that green North Pole-oriented plasma oriented toward the Earth. And the South Pole is on the opposite side of the Sun at the moment. We're pretty much right in the middle of the North Magnetic Pole at the moment. There's the latest image. And we'll also look at the line of sight field plot. You can see all of that North Pole magnetism there oriented right toward the Earth. So coronal holes are not really that well defined. That's our line of sight field plot. Let's move to the coronal hole line of sight plot. We do have some North Pole oriented coronal holes here. The only South Pole orientation that we see is just at the beginning here. It's kind of on the opposite side of the Sun, but near the south heliographic pole. So these are all North Pole oriented coronal holes here. You've got, that's north. Okay. All right. Let's try that again. That's north. That's north. That's north. These are even North Pole oriented. So that's what's going on with coronal holes. The current coronal hole high-speed stream is from this coronal hole right here, rotating toward the western setting mode. And let's move to sunspots. So again, we may have a new one forming down here, and we may have a new one rising up here. We'll show you some high-res imagery toward the end of the space weather segment of this video. Let's move on to look at sunspots in some greater detail. So here's 94 angstroms plus SDO continuum. That is the past 24 hours. And let's subtract the 94 angstroms to show just the sunspots. Which brings us to energetic particles and solar flares. So first, the GOES proton flux, where we don't see any spikes despite several M-class flares. And we've seen at least 4 M-class flares here since yesterday. Let's take a look at those in some different wavelengths. There's 94 angstroms all by itself. And as we forecasted, most of the flares came from this setting region up here in the northwest. Some flaring also came from this sunspot here. Well, I'm sorry, this sunspot down here. Anyway, you'll see the flares happening in the imagery. Here's 131 angstroms also. Interestingly enough, we did see some relativistic particles strike Lagrange point 1. They just didn't make it to Earth. And here we've combined those two wavelengths. That's 131 plus 94 angstroms. Those are the two best wavelengths through which to view solar flares. They take 10 images per minute instead of only 2 images per minute. That's half an order of magnitude of higher temporal resolution for the 131 and 94 angstroms wavelengths from SDO. They're specifically formulated to watch solar flares. So let's take a step back here and orient ourselves as we encourage you to look up. And we're always interested in what's going on overhead. The sun just rose over Lehigh Valley, Pennsylvania. The sun just coming over the horizon there, chasing Mercury. If you're up before dawn, you may see the dim fastest planet in the solar system, Mercury there. If you've got a low horizon and low light pollution, you may be able to see that. Also, we've got a crescent moon up there. Let's do a solar system forecast. This is the location of objects in a solar system station. We'll advance it 1 week. Don't be a space geek. There's where things will be in a week. We will have a crescent waxing moon by the 22nd. And next we'll take a look at coronagraphs. So here are coronagraphs from yesterday, and you will indeed you'll see some relativistic particles strike the aperture there. You see all these little like rectangles showing up on the imagery. Those are relativistic protons. So do those particles make it to Earth? Well, not in any detectable manner. Keep in mind, Lagrangian point 1 does not have any sort of magnetic shielding. So that's yesterday's imagery, 80 frames. We'll also show today's, an additional 40 frames there. And one of those coronal mass ejections may have an earthly directed component there. It's definitely a good candidate. I think it will probably miss to the southeast. Keep in mind, like from this perspective, Earth is kind of moving in this direction. And let me fix Epic Pen here. We just recently did a software update, so we've got like the wrong color. Just a minute. We appreciate your patience here at the Smash News Network, least busted name in news. So keep in mind, Earth orbits in this direction. So if a CME misses a little bit off to the west, Earth is more likely to strike it than if a CME misses off to the east, because it is moving to the west, orbitally speaking. Anyway, let's continue on here to show some additional imagery from stereo A. And that stealthy looking CME that we saw, let's bring this back. Not really showing up there. We got a bunch of missing data, it looks like. A lot of missing data. But if you look at this image, you will see that stealthy CME. Oh my gosh, please function. Wow. All right. Well, folks, it's about time for me to take this computer, unplug it, and throw it through the window. So you can see a little bit of ejecta there, sort of all around the aperture. Again, that CME may have a tiny earthly component. If indeed it does, it should show up around mid to late day on the 18th. It won't produce a major signal. It's very diffuse. So here's the past 24 hours zoomed way out. Here we'll zoom in a little bit closer. A prime example of relativistic particles making it to the SOHO spacecraft and not making it to Earth in a detectable fashion. And an even closer look here. That little interference pattern showing up there, an indication of some very high-speed protons showing up. Primarily hydrogen nuclei, most likely, also some electrons, some helium nuclei, and some other heavier elements. We'll also look at filaments, since there are a massive number of filaments on the Earth-facing portion of the solar disk. Here's the ground-based solar observatory at Cerro Tololo, Chile. And check out all of those filaments. This prominence down here is known as the Hulk Hogan. Did it eject, or perhaps it collapsed? Looks like it's in the process of collapsing there. We've also got the Patrick Stewart and several other filaments that could get names. Will you name the next filament after your friends and/or foes? Well, the place to do it is to name them after living people on our Twitter feed. So we also share auroral imagery over there and lots of other stuff, like facts about certain big tech organizations. But now we're talking about naming that filament. An important feature of space weather. Solar filaments, they can cause geomagnetic storms when they strike the Earth. So name some filaments after living people, why don't you? Don't name this one or this one. That's the Hulk Hogan and that's the Patrick Stewart. The rest of these are all free to be named. So name some filaments. Follow us over on Twitter if you don't have an account. Why not get one? And one more little comment. I feel terribly for you. I feel terribly for you. You're doing such a fine job with your slothware. You can also find a link to the Hemp Lucid free mushroom gummy samples. It's pinned to our Twitter profile. You can also find links to the Hemp Lucid shop below the video in the description. Save some cash by entering the promo code SMASHOMASH10 on checkout, or just use the link to shop. Lots of different solutions to sleep, immunological, stress, and more. So check out those products. People are loving them. The quality is very high. And here's the past 24 hours of SDO 171 angstroms. My personal favorite wavelength, if I had to pick one, I might pick 171 angstroms. It's quite nice. It shows a lot of character in the lower corona. So that's the past 24. Here's the past about 2.5 hours from SDO, not SDO, GOES 16 SUVI. Wow, this computer is about to be thrown through the window, folks. So fortunately, Smash Team members have been donating some cash via subscription services, gold annual paid-up subscriptions and annual monthly subscriptions and so on. So thanks to Gold and Silver Smash Team members, we're going to upgrade the hardware here pretty soon. We might even start running Linux to have a secure and private and functioning computer. Anyway, keep an eye on this region up here, as it is still certainly capable of producing large flares. In fact, it's just produced one right there on the video. So that brings us to our bonus feature segment. So let's blast through this. We've got some significant charging hazards here at the moment. Some significant surface charging over Mexico and moving into the Central Pacific Ocean. Those surface charging hazards are caused by low-energy electrons building up on the outside spacecraft. That's our Satellites Community Dashboard update for you. You may see some communications breakdowns. You may see some problems with weather satellites, things like that. There is the GOES electron flux for the past 3 days. And yeah, we see a cratering of the electron flux, as we typically do see with coronal hole high-speed streams. No real surprise there. Continuing on to the NOAA forecast, NOAA expecting a precipitous dip in the electron flux. And the next data point will probably be down here instead of up here, but we'll see what happens in tomorrow's video. Make sure you tune in for that, since there is no competition for our daily space weather. There's the one-year graph to put the relativistic electrons in context. Those are measured by the GOES 16 and GOES 18 in their geosynchronous orbits. They measure that electron flux at the F layer of the ionosphere using radiography. So let's take a look at that layer of the ionosphere in vibrational frequency. It's the bridge between Earth and space. So there's the raw vibrational frequency. That's megahertz, millions of vibrations per second. We've certainly got some high-frequency anomalies happening. We'll also show the anomalygram. That's anomaly in megahertz from a 30-day median. You can see lots of blue there. So high-frequency anomalies, especially around the Eastern Pacific, around South America. Really global high-frequency anomalies happening there. That's anomaly in megahertz from a 30-day median. Great example of the location of the South Atlantic anomaly and so forth. Here's the latest image. That's 12:15 universal time ionogram, and there's 12:15 universal time anomalygram. Will also show the total electron content. That's the free electrons between your GPS satellite and your handset. Feel free to pause the video on this frame if you're not familiar with the locations of things like the Van Allen belts and GPS satellites. Here's your total electron content forecast, and we're seeing huge GPS errors all around the world here. So as you may have expected with a coronal hole wind stream showing up, huge GPS anomalies happening. Also some low electron content anomalies in these bands. You see these little bands right here. And also some low electron anomalies over the South Atlantic anomaly and over the Central Pacific, the Caribbean, and Southern South America. We'll let that play through one more time, and then we'll show the latest high-res imagery of the closest star. And thanks for stargazing with us. By the way, the reason we do the daily space weather videos is because of the advancement of cosmology. Yes, I realized in the mid-90s there was a hole in the field of cosmology caused by heliophysics. So there's the latest intensitygram. There's the latest colorized magnetogram. Let's check and see if this region is now a sunspot. Not so much. At least not yet. Could be an umbra forming there, so that's an area to keep an eye on. And when I say ion, well, pardon the pun. And that region up there is just a plage. No dark umbrae visible there. There's your rock back once more. And before we get to meteorology, don't forget to visit our website. So smashomash.com is the homepage, and welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Apparently it's very hard to put out videos that don't include propaganda and nonsense. So in any case, it doesn't matter to us. We'll keep citing facts and calling balls and strikes permanently. Never cash in your credibility, folks, because if you cash in your credibility, you'll probably never get it back. Smashomash.com, all kinds of links on there. Links to the Twitter, links to the Instagram. Make sure you follow us over there for exclusive content. By the way, more sponsorships and affiliates coming soon. Smashomash.com. And make sure you press like and subscribe. If you're new to the channel, press the subscribe button, press the notification bell. No guarantees that YouTube will actually notify you when we put up a video. But if we get 50 likes, we will stream live on YouTube. Thanks to our YouTube subscribers. If you're viewing the videos on BitChute, make sure you subscribe over on YouTube. You're missing most of the content. And let's go to meteorology. So a great way to bridge the gap between space weather and Earth weather is the aurorae. So we've currently got some since we've got geomagnetic storm conditions. These are the likely places to see aurorae there, moving into Siberia and so on from Alaska in the north. And possibly there are some aurora visible in southern New Zealand and Tasmania. Let's get to meteorological stuff by switching to the surface wind conditions of this side of the planet. So there you go, the eastern surface winds depicted here, the jet streams of the east depicted here. Shout out to our viewers from this side of the planet. Shout out to our viewers from the west side. It's the west side. There's the jet stream situation for the western world. Chaotic jet streams there over South America. Here are the surface winds of the west. Strong winds in West Texas there, blowing from Mexico into El Paso. Here are the surface wind scenarios for the central world. Shout out to our viewers from this portion of the planet. And these are the jets. The jets of the central world, Europe, Africa, and the Middle East depicted here. Let's move on to check clouds and fog over the Americas. So that's 3.9 nanometer infrared radiation as NASA's interactive weather satellite suite projects the imagery of a croissant-shaped Earth onto a spherical globe. Next, our weather.gov map. If your location's lit, click your location. We've got some blizzard warnings there in Minnesota and the Dakotas. We'll briefly scroll down so you can see the key. It's weather.gov, if you're wondering. Looks like some severe weather around Hawaii. Also, lots of winter storm warnings across the central U.S. and some heavy winds on the Great Lakes. Let's show some forecasts, starting with temperature anomaly. So we've got some anomalously warm weather for the next couple of days in the eastern portion of the country, as high as like 20 degrees Celsius above normal. That's your GFS 72-hour temperature anomaly forecast in degrees Celsius. Cold weather in the west. Next, your pressure and precipitation forecast. Again, we've got some significant ice storms. We reported on it yesterday. And some heavy snow there coming to the central part of the country and then moving up to the northwest, to the northeast. So you're going to see some major icing in there as well, starting in mainly Illinois and then moving up toward the Great Lakes. 72-hour GFS pressure and precipitation forecast is looking like this. And we'll also show the total accumulated positive snow depth change. That's the positive snow depth change for the next 72 hours based on the GFS model as well. So heaviest snows there coming to eastern Nebraska, it looks like. Also western Iowa and Colorado, despite all the hot air coming out of the state of Colorado. Lots of snow falling, blanketing most of the state with some new white stuff. Continuing on to our windy.com map, there is the next 3 days of new snow based on the GFS model, and there are the next 3 days of snow based on the Euro model. They're pretty consistent with each other there. The Euro model shifting it a little bit to the west. A lot more snow for Arizona in the Euro model than the GFS. Again, there's the Euro model for the new snow of the next 3 days, and there's the GFS model for new snow for the next 3 days. The GFS model predicting much heavier snow for West Virginia as well. Continuing on here to our NASA Goes Lightning Mapper. We did see some lightning across the country here, mainly in Arizona. Some pretty significant thunderstorms happening out there. And let's see if there are any current terrestrial strikes by taking a quick look at lightningmaps.org. Lightningmaps.org, your real-time lightning map. We think it's great. And we saw at least some strikes there in the Gulf of California. Besides that, things looking pretty calm. No terrestrial strikes in the U.S. at the moment. And let's close this mother out by looking at the U.S. Doppler radar map, if it loads. Ah, yes. Radar.weather.gov. Let's press refresh to show the real-time Doppler radar map. So that's what's currently going on. We'll focus on the lower 48. So that's vertical motion of water droplets and ice crystals in the air column. Here is shortwave radiation showing clouds and fog, we hope. Or maybe not. All right. No, that's okay. We'll wait. We've got to reinitialize these images, folks, so just give us a minute here. The dangers of streaming live. By the way, we actually enjoy streaming live. It creates tension that would otherwise not be created, and hence creates content that would otherwise not be seen. So here's shortwave radiation showing clouds and fog, a bunch of low clouds over the Atlantic and the Gulf. And here is water vapor. Seems a little slow. There we go. And here's your recap, the U.S. Doppler radar map. That's radar.weather.gov, by the way. Here's the NASA GOES Interactive Weather Satellite Suite 3.9 nanometer shortwave radiation map, part of the infrared electromagnetic spectrum. And there is water vapor. Thanks for tuning in. Once again, don't forget to press the like button. If we see 50 likes on this calendar date, we will stream live to YouTube. Thanks to everybody for tuning in. Thanks for leaving comments, Tinman1057 and Mike Bordages. We'll see you soon here at the Smash News Network, least busted name in news. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.